was a wonderful experience, one that I'm very glad to have had and feel privileged to have had as well. Google has grown hugely and had grown hugely before I started, but just a wonderful software engineering environment full of fascinating systems everywhere you looked. Interesting things were happening. The physical presence of these companies was very clear in San Francisco, which is where I was living and working, and it was impossible to walk across the city block without seeing an autonomous vehicle on the street, and often many of them. Essentially building a new vehicle, bringing a new car to market is a very challenging thing. You've got all the logistics of the bill of parts of thousands of pieces of sophisticated machinery that you're getting from all over the world, having to assemble, having to make sure the fleet is there. It's very challenging.
Welcome back to a brand new episode of Business Unbound, where we dive into conversations with visionary leaders from every corner of the globe to bring you insights, inspiration, and the real stories behind success. I'm your host, Florian Hoff. Today, I'm joined by William Mee. Will started his career as a software engineer at Google in 2009, where he spent nearly a decade working on products like Google Maps, and also on various Android developments. After leaving Google, Will moved through a few roles at Thumbstack and Coda before joining Zoox, an Amazon company that develops self-driving vehicles, where he worked as a software engineer. At Zoox, Will worked on the fleet orchestration and dispatch system, so he built critical infrastructure for managing self-driving vehicles as they operate in cities. But his experience gives him insights into the broader self-driving vehicle industry. He's in the know about what's actually possible, what's challenging, where the real obstacles are, and how different companies are approaching this problem in fundamentally different ways. Then, in 2025, Will made the decision to leave that role at Zoox and pursue an executive MBA degree at UC Berkeley's Haas School of Business, a move that reflects his thinking about the bigger picture, the business challenges and leadership questions that sit alongside the technical ones. Today's conversation is, well, a masterclass in self-driving vehicles for anyone trying to understand this industry without becoming an engineer. We are going to explore what it actually takes to build self-driving technology, the different paths that companies are taking, where the industry stands right now, and what the real barriers are to mainstream adoption. We'll dig into technical challenges, safety questions, and business model through the lens of someone who's been building this technology in the real world. If you've ever wondered whether self-driving cars are close, whether they are actually safe, or what the bottlenecks are to making them work at scale, this episode will give you a much clearer picture. This is Business Unbound. Let's dive in. Quick moment of honesty. Business Unbound is brand new. We're in the early days of something that I genuinely believe in, a show dedicated to real conversations with forward-thinking business leaders and inspiring individuals who are having a real impact on this world. And that's where you come in, because I need your help. If you're watching this on YouTube, please like, comment, and subscribe to the channel. If you're on Apple Podcasts, Spotify, or really any podcast app, please follow the show and leave a rating. It may sound simple, but it actually shows the algorithms that this content matters, and it directly impacts how many ambitious professionals like you discover these conversations. When you're helping me, you're not just supporting the show. Here's what you're really doing. You're saying that quality business conversations deserve a platform. You're saying substance matters over hype, and you're saying this mission is worth building. So if this resonates with you, please help me reach others like you. Subscribe, follow, share, whatever works for wherever you are. You're helping me build something substantial from the ground up, and I genuinely appreciate it. So thank you. And now back to the show. William Mee, welcome to Business Unbound.
It's great to be here, Florian. Thanks for inviting me.
Will, you are a highly experienced software engineer. I think that's absolutely fair to say. And you have worked on frontier technologies for most of your career, including at Google. But before we dive into deeply, can you take us back to the beginning. How did it all start for you?
Yes, and my career started actually quite a lot before Google. I was lucky enough to graduate, do my undergraduate as the internet in the commercial space was coming online, and that was a very exciting time. And I was in the first graduate class, the undergraduate class that got access to the internet as we were completing our computer science degree. And then I joined a service provider as all of the big companies were getting onto the internet for the first time. So this was one of several big pivotal changes that I've experienced in my career in tech, and it was a very exciting one. And that's not to date myself or anything, but I'm just going to say that was in the late 1990s, as all of these technologies were becoming commercially viable for the first time, and the network of networks, which is the internet, was coming to be widely adopted.
Hmm. And then you actually went on and started working at Google at some point in your career. And I understand that you worked in a few different roles. Google is sometimes seen as the pinnacle of tech companies, and I would be surprised if someone told me they are not interested in Google. Could you take us back a little bit to your time at Google and just explain on a high level what it was like working in an organization as such?
With pleasure. I was at Google for just under 10 years. This was between 2009 and 2019. And it was a wonderful experience, one that I'm very glad to have had and feel privileged to have had as well. I was doing a master's in computer science at Columbia University, and then I managed to get 2 year-over-year internships at Google. And then based on those experiences, which were by themselves great as a student, I began working at Google full-time in 2009, and it was and is in many ways a tremendous company for its engineering culture. It's changed, of course. Every company changes. Google has grown hugely and had grown hugely before I started, but just a wonderful software engineering environment full of fascinating systems everywhere you looked. Interesting things were happening, and also just staffed by excellent and very smart and very creative, funny, and engaged people. And so in all of those respects, a really great place to work. And just had a lot of interesting experiences within Google. As you mentioned, I worked on various different products. Google, one of the many wonderful things about Google is the internal mobility is high, and it's encouraged that you move from place to place. And so it's relatively easy to be, and also because of the size and scope of the company, to move around. And so being able to move, in my case, from something like AdWords to Maps was relatively straightforward, and each of those had their own special applications, even though a lot of the basis software within Google is the same.
You explained that you stayed on with Google until roughly 2019. What made you decide to leave eventually?
I was just concerned. I'd never stayed and worked at a single company for that long in my career up to that point. I was also just really loving Google, and I thought if I don't leave now, maybe I never will. I was also aware of the diversity of the technical landscape outside of Google, and there was a sense of parts of the tech experience which Google, with all of its technical excellence, was not giving me. If you want an analogy, Google is something like a cathedral, and there was a very vibrant marketplace outside of the cathedral, which I hadn't spent much time inside of.
And then you spent a few years working at different companies, and then I believe in 2023, you joined Zoox, an Amazon company that is developing self-driving vehicles. And that's also the main theme of our discussion today. But what made you interested in this space of self-driving vehicles in the first place?
I had been interested in them already while I was working at Google. Most of the self-driving projects have had their genesis in maybe the year 2013, somewhere around there, or 2014. And so Google's self-driving project, which is now Waymo, was already in full swing within Alphabet while I was working there. But in 2023, the physical presence of these companies was very clear in San Francisco, which is where I was living and working, and it was impossible to walk across the city block without seeing an autonomous vehicle on the street, and often many of them. And that was definitely part of it. There was an excitement. There was like, this is a new thing and a very visible piece of technology. And beyond that, for me, there was the attraction of for me personally, the novelty of a company which was not just doing software, which I spent almost all of my career in, but also doing hardware. So there was this robotic aspect to Zoox. It was not only building the software to control its vehicles, but also building the vehicles itself, and that was very exciting.
It certainly sounds exciting. And you worked in particular in fleet orchestration and dispatch systems. I think that's how it's called. And to me, as I'm not from this industry, it sounds a little bit like air traffic control for robots. And perhaps without getting too technical, can you explain what your role actually involved, what you were working on?
Yeah, with pleasure. Perhaps not quite as exciting as you think if you just make the analogy to something like Uber. The software that I was developing within Zoox was solving that essential challenge in a ride-hailing system, which is a fleet of vehicles and a group of passengers, and the matching between them, and making sure that the optimal vehicle gets sent to the passenger so that their experience is as good as it can be given where the state of the fleet.
With all the considerations like, okay, where's the car which is closest by? How much battery does it have left? Can it actually complete the route that the customer wants to take? Keeping in mind probably also where's the next charging station. Is that about accurate?
Exactly, all of those things, and so many of those are things that a ride-hailing company like Uber or Lyft does as well. In our case, the additional excitement and complexity came from the fact that our vehicles were autonomous.
And perhaps before we dive into the technology of self-driving vehicles a little bit further, in terms of your background, you then eventually made the decision to step away from your role at Zoox to pursue an MBA degree. I think at the time you've already started the program and then decided that you wanted to spend more time on that with a clear priority. And I'm wondering a little bit, what prompted that decision for you?
Yeah, I had indeed worked and done the MBA in parallel for over a year. And the initial decision to do the MBA was something which I'd had in the back of my head for a long time. In any modern profession, this is true, but in tech, it's particularly true that change is the constant. That tech is changing so fast, and you always have to keep up with it. And I have appreciated that and been running through that cycles of innovation and change throughout my profession. And I thought that to really keep abreast of the change, at some stage, I had to go back to school and to look at how I could change with the help of a program behind me. And that was also something which would allow me to take on a broader perspective. I had worked in tech for decades, and I love it, and I've gotten a lot out of it. But I was also aware of the fact that it demanded only a subset of the skills that I have, and I was ready to invest in some of those other facets of my skill set, which I think I can harness for the next decades, and I'm really looking forward to being able to move into a different space. I don't think that I'm going to be ignoring tech. I think tech is in every profession in some way. Then it's in every sector. So I'm really glad to have the background, but to be able to think of the business side and to move into that framing of like it's the technology is very important, but there are economic and operational aspects, and definitely those were part of the Zoox experience as well.
And allow me perhaps to ask one follow-up question on your executive MBA program. I've done one myself, and when talking with others who have completed a program as such, the question that sometimes arises is, would you do it again? Do you think it was worthwhile for you? How would you answer that question?
I'm not sure that I would do it again, but it's a huge, in the sense of, perhaps I'm misunderstanding the question. I would think twice before doing something this heavyweight again in the next years. But do I regret it? Absolutely not. So if that's what you're asking, if I have any remorse for having embarked on it, not at all. I think it was a great decision to have made. Certainly had some negatives. Was much harder to combine with everything else, every other pressure on my time than I was expecting. Perhaps I was naive, but I feel like I have gotten so many benefits and met so many interesting people and had my horizons expanded in a way which is really precious to me. Whether the MBA is going to have purely financial return of investment is something which I cannot say, but in terms of the experience that I've had both professionally and I think as part of my lived experience, it's been a really remarkable couple of years, and I'm very glad to have had it.
And that's certainly an experience that I would see similar to you when I think about my own MBA program. Now, Will, when we talk further about self-driving technology, let's maybe start very simple and basic technological terms. And when you think about what it takes to build a self-driving vehicle, where do you start explaining it to someone who's not an engineer like me?
Yeah, I think a good way of starting to think about a self-driving car is that it's a form of robot. It's one which has a very particular use case and looks in some ways familiar because we're used to these vehicles, cars in our case, being on the roads. But it's essentially it's an advanced robot, and so on that basis, it's got multiple things that it needs. It needs to be able to be autonomous. It needs to be able to make decisions, and there are complex AI-based systems which are on board. They're not running on the cloud. They are actually on the vehicle, and they are working together to achieve the autonomy. And then in parallel to that, of course, you have to have the perception of where the robot, where the vehicle is. So you have a set of sensors which are providing the vehicle with its perception of its environment. And so you'd have LiDAR, you'd have radar, cameras, GPS, etc., and that's providing an input into the AI systems.
Right. Okay. So the car has sensors. It perceives its environment, or maybe it's not even accurate to say the car, because in the case of Zoox, it's, I think, not a car technically. It's a purpose-built vehicle. But in any event, the vehicle has certain sensors to perceive information, the environment that happens around it. What happens next? What does it do with these information?
Right. So it's sensors, if you like. You can think of this as the genesis. So it's got LiDAR, which is making use of laser to get essentially a point cloud measurement of the objects around it. it's GPS, it's cameras, things like accelerometers. So all of these are being fed into AI systems, which are giving structured understanding of what the environment is. So some examples of that are that it could be able to categorize part of what it's sensing as the road surface, part of it as another vehicle, part of it as a person. So these kinds of problems, these are essential for the kind of high level decision making. So there are networks which are doing things like object detection or that segmentation that I was just talking about, and then there are other components which are doing things like prediction. So based on what the vehicle is sensing, it might have identified that there is another vehicle, say, and it might then use the measurements of speed, etc., that the identified vehicle is doing to be able to predict this vehicle is going to change lane. And that might, of course, there might be other signals such as a flashing indicator, and all of those, that fusion of different sensing into a prediction model is another part of the logic of what the autonomous vehicle is doing. And then there's a planning component as well. So that takes the autonomous vehicle state and it decides on what it is going to do in response to the prediction of the environment around it. So this vehicle is just about to change lanes. So the autonomous vehicle, my robot, is going to slow down to allow it to get in, for example. And that's three major components, and then there are multiple other aspects which are kind of cutting across those different components. One of the important ones is a collision avoidance system, which would make which has as primary target that if there is some aspect of a collision, a sudden braking, for example, it kicks in and takes over the minimization of the risk of a collision.
I'm starting to think a little bit back. I used to have a Volvo a few years ago, and that Volvo was built in 2016. What that Volvo was already capable at the time of doing was it could keep its lane, it could keep its speed, and it could automatically adjust the distance to the vehicle that was driving in front of me. What you explained, like with the perception and the prediction and the planning, it reminds me a little bit of what this car was already able to do 10 years ago, about 10 years ago. What happened since then? I mean, was it a gradual improvement that was made, or is there a leapfrogging moment somewhere? What progress was made over the last decade?
Yeah, we've had these kinds of technologies literally in our hands for many years. It's a spectrum, and so things like the ability to warn you when you're changing lane unexpectedly, cruise control, assisted driving. There's a spectrum of autonomous driving or autonomous vehicles, which is defined in the industry starting at level 1 and going all the way through to level 5. The kinds of things that you're talking about are on the low end of that spectrum. So L1 would be these kinds of driver assistance where you cannot take your hands off the steering wheel, but the vehicle is helping you in some way. We have been working, it's been a long journey, but over the last decade plus a couple of years, we have these teams of smart engineers and researchers have been working on these kind of tough problems to get the vehicles slowly increasing through these levels of autonomy to the levels that we're at the moment, which will be level 4 in the case of something like a Waymo. So that journey has been one which has been slower than we were anticipating. There have been many predictions made about autonomous vehicles that have been saying that we should already be there. But we have been making steady progress over the last decade. And you could think about like how some of these technologies could have been very successful on closed, protected environments. So in some kind of like track or test environment, or even something like a warehouse, driving around inside of a warehouse, but might not have been robust enough to be on the public streets. So it's that making the safety and other changes to get the techniques that have worked in a controlled environment into the much more chaotic environment on streets, which has been a lot of the challenge.
And if we talk more specifically about Zoox, I think the company has been around since 2014 and was acquired by Amazon around 2020. And just for our audience members who may not be familiar with Zoox, I understand that a purpose-built vehicle, which was designed from scratch to be very autonomous. So they are not basing their work off the idea that you can retrofit a regular car with sensors, but instead it was built from scratch to fit this purpose of driving autonomously. From your perspective, what are the pros and cons of this approach?
Zoox is a unique looking vehicle, and you might, if you're not looking closely, not really see that something like a Waymo is an autonomous vehicle, although it's got certain sensors which make it distinct. But Zoox looks very different from any car that you would otherwise see on the road, and this has been something which other companies have wanted to do. It was also part of some of the possible paths that Waymo could have taken earlier on. But it's been the core of what Zoox has done from the get-go. The motivation to design your own vehicle as part of the autonomous development allows you to do things like just rethink the entire mobility challenge. And to think of the amount of, just as an example, you have space inside of the vehicle. You don't need a driver. You can use that space, and so why not reconfigure how the vehicle is, and so you can make it a more social space where people are facing each other versus sitting in rows. And it also allows you to make some precision implementation of things like turning, to give a very tight turning circle, and this is something which is really unique about the Zoox vehicle, to make it bidirectional, so the vehicle can easily go in one direction, and then in certain circumstances it might have parked, for example, and it might come out, can go at the same speed in the other direction, and its lights will switch, and headlights become taillights become headlights, and this allows a much greater mobility under certain circumstances, and it allows the full power of the autonomous driving to be taken advantage of, you designing the hardware alongside the software. And obviously, in terms of the cons, this is something which is complicated. You are dealing with essentially building a new vehicle. Bringing a new car to market is a very challenging thing. You've got all the logistics of the bill of parts of thousands of pieces of sophisticated machinery that you're getting from all over the world, having to assemble, having to make sure the fleet is there, and having to do this in lockstep with the software. This is a very challenging project to undertake, and if you can allow a specialist company like Jaguar to do this for you, it allows you to concentrate just on the software. And there's a whole spectrum of approaches in autonomy. Zoox is I think special in that it has decided to do everything itself.
And the hardware and the build of the vehicle itself is one aspect. And in terms of your reflection, when you look at the industry, across different companies who are active in the self-driving vehicle space, at least to me as an outsider, they seem to be making very different choices when it comes to their technology. What are the major decisions that they face? Why do different companies choose different technology outfits?
Yeah, there are different contexts that they're in, and sometimes they are making their choices on the decision we were just talking about, the like how much hardware is going to be built alongside of the AI, the autonomous software, and there are companies such as in the trucking space, the Aurora Driver, where they're not even thinking about a single vehicle. They are building a unit which can be fitted onto multiple trucking platforms, and so they do have some hardware component, but it's something which they're intending to be able to embed in a variety of different trucks. They are giving the software and the APIs and the services, but not the actual vehicle. So that's a big one. And then there are certainly alongside this, if you think of the amount of variety in some of the players in the space, one company which comes to mind quite quickly is, of course, Tesla, who has already had a self-driving mode in their passenger vehicles for some time, and is now very aggressively leaning into the autonomous space with its robotaxi fleet. And they are making decisions on what kinds of hardware and sensors to use. And of course, in their case, they are taking advantage of a hardware platform which is already in the hands of hundreds of thousands of people.
So Tesla has purposefully decided not to use LiDAR as a sensor. Is that correct?
That's correct, and that's an interesting decision that they've made.
And this is mainly because cost benefits, or what is the reason based on how you perceive what is happening?
It's definitely cost. LiDAR is vastly more expensive than a camera, and so Tesla's decision has been to rely solely on camera, so that they don't use either LiDAR or radar. That allows them to use inexpensive commodity hardware, and that allows them to scale much more quickly. In some ways, they don't have to worry about the multiple sensor streams that they are getting. They just have the visual. And the approach there is to think of the autonomous vehicles as being able to do what humans can do. Humans do not have LiDAR. We don't have radar. We maybe use a little bit of sound, but we are mostly relying on just the light that we have, that we can see. And so the thought there is, if the processing of the video imagery is good enough, it should be sufficient. And so that's a different philosophy. And it's certainly been controversial in the industry.
What's your take?
I think that it has brought a measure of disrepute to the industry, because it's being marketed as a autonomous vehicle in the same way that a Waymo is an autonomous vehicle, but there are clear disadvantages in the current development of the processing of the AI side. It's difficult for video-only systems to handle low light in the same way it would be for a human, or glare or snow. They have to deal with much more challenging perception calculations because they don't have the measurements from the LiDAR. So I think that this is definitely a trade-off, and I think that there are disadvantages to doing it. And I think the bad press that gets generated from issues with Tesla having problems, and there have been multiple accidents with Teslas in self-driving mode, gets reflected onto the industry as a whole, and that's problematic for the industry.
If we transition away a little bit from the hardware side and sensors, there's obviously also the software side on which you also worked, and decision-making algorithms in particular. Can you perhaps talk about what the software side involves and how companies like Zoox and also others in general terms approach building the software systems that power the self-driving vehicles in the end?
Sure, I'm happy to do that. I'm just going to call out that I'm not an expert on this because this is on vehicle software versus what I was working on at Zoox, which is off vehicle software, but I have a broad understanding of how it works. So the systems, I talked about the three different kinds of components that are on vehicle, and at least two of the three are using deep neural networks of different configurations, and so these are networks which are trained, and so there are training runs. So, for example, object detection, to be able to take something like a video of a street and to be able to detect that this part of that video is a car. This is something which is trained. And so the neural networks, which are using these deep learning architectures, CNNs and others, they are trained through many runs, and that's why in cities in which the vehicles are being rolled out, you will see training missions. This is something which is very physically clear. In San Francisco, there will be vehicles driving around with safety drivers, and they're doing training runs. So they are training these onboard systems. And then alongside these training, these physical training systems, a very important part of the software development is simulation. So this allows the onboard systems to get access to variations of some of those physical training records, and for all kinds of worst case scenarios to be replayed or to be developed. And then just one other thing to call out is that another aspect of the software is very detailed maps. And so at least in the current state of autonomy, the vehicles are not able to go onto an unmapped road and drive in autonomous mode down an area which has not been mapped out by these three-dimensional and highly detailed maps, which are not the same as the data that you get from something like Google Maps.
And when you were explaining different technological components that make a self-driving vehicle, you seem to have touched a few times on the broader topic of AI in different capacity that is being used. Obviously, there are many things happening in AI at the moment, and it feels to me that it's almost being used synonymously with large language models, like everyone knows ChatGPT. So to what extent do you think that the various advancements in AI also impact the development of the self-driving technology?
There's definitely an impact. Some of this has to do with how we are taking advantage of the architecture which is behind large language models. And so a lot of the large language models that we are using today are based on what's called the transformer architecture. And this hasn't traditionally been used for autonomous vehicles, but there are definitely ways in which it can be. It can process in parallel things which previously were done sequentially. And so there are applications, and there's early fusing of multiple sensors, which can also be done by the transformer architecture. And so that's one way that the changes that we're seeing in other parts of the AI realm is impacting autonomous vehicles. But then also, of course, there's this tremendous increase in the hardware and the GPUs and then the power of the GPUs, which we're seeing. And so this is not really related to the large language models, but the whole AI ecosystem is accelerating, and so the training, the data centers, and other infrastructure which the autonomous vehicles are using is also benefiting from the general investment in AI infrastructure for sure.
Right. You mentioned transformer model and sequential models in very simple terms. If there is a simple way, can you explain what these models entail?
The transformer model was the breakthrough which led to something like ChatGPT being possible. The transformer model was originally in the realm of machine translation, and what is special about the transformer model at a very broad level is that it allows so-called attention to be given to various aspects of the stream of tokens that the model is looking at. In the case of translation, these would be words, or representations of words. In the case of an autonomous vehicle, it might be a representation of the imagery which is being taken. But the transformer has multiple of these components, if you will, that are giving attention to different things in parallel to the stream of tokens which are going through, and that allows it to have a much richer understanding of what's going on. The sequential models, LSTMs and others, these have been around for longer. They predate the transformer model. And those allow us to do things like to process an audio sequence, and so something where you call out to a smart speaker, for example, and say, hey Google or Alexa, please do this. They can figure out those trigger words. They can also do the speech to text translation, these kinds of things. So those have been around for a long time, but they are just looking at the head of the data. The transformer is looking at multiple things at the same time, and that was probably more explanation than you were asking for, but it's a little complicated as a topic, and I'm sorry if I didn't do a great job of explaining it.
No, I do appreciate this, and to me, the technological aspects they are fascinating, and they are not the only challenges when it comes to self-driving vehicles. Like operations also seem to be rather complex, fleet operations in particular. From your experience, what do you think are the main challenges on the operational sides that these companies face when they are trying to run a fleet of these self-driving vehicles?
I'm really glad you brought this up and asked about this, Florian, because it's a really important part of the autonomous vehicle system as a whole, and it's one which is not typically focused on. But yes, you would have a large set of operators that are helping with the fleet, and you could imagine that a company that has vehicles on the road, if there is something, especially in actually for all vehicles, but like for a Zoox vehicle which cannot be driven, the need to be able to drive it remotely is part of the tasks of the operators, and so for Zoox, as for other companies, there would be so-called disengagements where, for whatever reason, the AI cannot continue to control the vehicle, and then it would be taken over either directly. So, you can think of this as being taken over with like a joystick-like mechanism, or with guidance, go forward, brake, from an operator. And so there are also these operators. They are using sophisticated software. They are monitoring multiple rides, and it's part of the cost of the autonomous vehicle fleet. And so how that's done and how this can be optimized is actually a really important part of the autonomous service. And there's been a lot of reporting on, for example, Cruise and what its state was back in 2023, and how many operators there were per passenger. So that's an example of a metric which is really important. You could imagine a situation where there might be like 1-to-1, like every passenger, every vehicle which is out there has, a human operator. That's clearly not something which can scale well, right? And so being able to make sure that there can be many, many, many autonomous vehicles which are only using a single operator is an important part of the scaling. And another thing is just reducing those disengagements. So again, a metric of like how many disengagements do you have? How many times does a human have to take over per whatever 10 miles, 100 kilometers? Those are kinds of important metrics, and being able to reduce those and to make sure that the fleet as a whole can scale as your Waymo goes to Los Angeles, it goes to a much bigger area and scales across the United States. That's really important.
Do you have visibility into, let's say, target ratios? What's the ratio that these companies want to achieve? One teleoperator per how many vehicles simultaneously? What's the target?
There's little public data on this actually, and I think that's deliberate. There was, and I think we might get back to this a little later on, but at the time that Cruise was in the media eye in 2023 because of various incidents, there were reports that there were 1.5 operators, 1.5 operators per vehicle, and disengagements every 2.5 to 5 miles, which is high. I think I would be surprised. I don't know either in Zoox's case or Waymo's what their rates are, but I can't imagine that they would be that high. For me, that's extremely high, but I don't know for sure.
Asking this question for the reason that there's a lot of discussion in self-driving vehicles about job replacement or jobs disappearing, the drivers becoming obsolete if self-driving vehicles scale throughout the world. And it sounds to me a little bit like, okay, maybe these jobs may disappear, but then there's also the teleoperator aspect. And while it may not be 1-to-1, it could be 1-to-5 or 1-to-10, which still makes the workforce smaller that is eventually needed to operate the fleets at scale. But still, this commonly held belief, this argument that all these jobs will disappear, yes, it may be true, but at the same time, these companies create new jobs which are required to be still executed by people.
That's a good aspect of what we've been talking about, and one that I hadn't thought about myself. But indeed, there's a wide set of skills which are needed to run a company like Zoox. The operators are part of it, but like mechanics, fleet maintenance, engineers to check batteries, all of this kind of logistical operation is quite intense, and it definitely offsets some of the gig economy loss of jobs. But you can also, many of these are more skilled, is worth calling out. And also, if you think about the goal here for a company like Zoox or Waymo is not just to provide like a ride-sharing services, Uber is doing at the moment, but to actually be able to allow more people to live without their own vehicles. And so then you've got a vastly bigger market that you're looking at. And so you'd be providing the service at a scale which is not just, that you need to replace the current, Uber drivers that might lose their job because an autonomous vehicle is taking them over, but you're providing a kind of a platform for a much bigger mobility service.
I've heard the other day that one of the jobs that will emerge in this field is also labeling data, and humans will be needed to label data, traffic data, or any data that the vehicles experience to help train the AI model to make them more efficient and more effective in the future.
That's actually a important part of the AI industry as a whole, and so there are prominent players. Scale AI is one of them that's been in the news a lot. But yes, this is really important. This is needed in autonomy in autonomous vehicles, but it's needed in many other parts of the AI sector at the moment as well.
Mhm. Now, when I go back to the framework that you and I started building as we had our conversation so far, we spoke about challenges in technology, we spoke about challenges on the operational side, and we have to talk about challenges when it comes to safety. And I'd like to start by stating that there's probably an infinite weirdness of the real world problems that can happen when self-driving cars move in their environment. They could be, I don't know, like a random person in a chicken suit or a construction worker holding a stop sign upside down. And there are like many edge cases and rare scenarios, but still they can be very important from a safety perspective. How do you think about this?
Yes, I actually have thought about it a lot, and it was often on my mind when I was lucky enough to be on some of the test drives. If you go from a relatively first of all, of course, from a test track, which is very controlled, but then you're on maybe a quiet suburban street. Zoox was the first company in the world to run a custom-built vehicle in autonomous mode on a public street, and they did it in Foster City, which is a relatively quiet part of the Bay Area south of San Francisco, and those roads are much more regulated and predictable than the first time that you drive in an autonomous vehicle through the streets of San Francisco, where when you stop and just observe everything which is going on around you, the amount of chaos is extremely high. There will be people in wheelchairs going down the road. There will be buses that there will be construction sites. There's so much that's there. There was there are videos that you can see online of some of what what some of the vehicles are seeing, and some of it is just comic. You can get really outrageous things, and an example of this, sometimes it's actually deliberate, so pranksters can do things as well. And a well-known example was a wave of what was called coning in San Francisco, where people would place cones onto the vehicles and confuse them, and so a vehicle suddenly has to deal with like an orange cone right in front of the camera and figure out what to do. This chaotic element is a big problem. This infinite edge case of like all of these things can go wrong. Why are there live fish flopping around on the street all of a sudden? Where did these come from? What do I do? Some of it you can train for. Some of it, so things like the jaywalking or the breaking of the rules that we're all used to on the road systems. These can be trainable. There's a certain amount of unexpectedness. There are other things which will always be so bizarre that you can't predict them, and how the vehicles respond to them is a core challenge. I talked a little bit earlier about disengagement, and obviously just being able to say that I don't know what's going on here and I have to disengage. This light has gone down and I'm surrounded by people, or there's a protest. Disengage and ask for external help is a part of that, but it's a real challenge.
I mean, especially in situations where the vehicle would have to make split-second decisions. And is the notion true that when the vehicle doesn't really know what it's supposed to do, that it just stops and waits for the teleoperator to help?
I'm not sure if that's true universally. I think there are different approaches. And a typical one might be that some kind of pullover, analogous to what a human would do to get out of the road if there's something which is happening. And this is certainly part of what makes freeway driving for autonomous vehicles challenging, and it's one reason that the freeway driving is coming after the targeting of the urban roads.
Yeah, I mean, I just thought in my own experience, I mean, just yesterday, there was in the area where I live, an Amazon driver who apparently lost his way, and he ended up on the sidewalk for some reason behind our house. And I don't know how he got there, but he had to drive out of it. He couldn't go straight, so he had to reverse and drive the whole way back reverse. And I'm wondering a little bit, okay, like, if a self-driving vehicle is trapped on this situation, what would it do? Well, then maybe that's a case for the teleoperator.
Yeah.
Another traffic situation that I observed not too long ago was when a car in a bigger city, and they had trams in the city, and for some reason the car ended up on the tracks of the tram, and it was tracked. And it was trapped on the tracks, and I guess those situations, they will also be very challenging for self-driving vehicles to navigate if even humans have challenges with all the capabilities and driving experience to do correctly in the real world.
100%. Some of those are really important to tackle, and some of the ones which have been in the press recently have been from issues like interactions with first responders, where there's some like unexpected situation. There's a police crime scene or an ambulance, and how do the vehicles respond? And what becomes important then is that there can be like external direction, because you expect that the vehicle can be somehow control or given signals by a first responder, telling it to stop, telling it to reverse. That the vehicle itself can respond to this. It doesn't have to be a disengagement and an operator which is responding to it. So that's something which has been very prominent because it's gotten a lot of press and a lot of political pushback in the Bay Area. But there are many examples of just situations which are unexpected and sometimes life-threatening, as you say, like you get stuck on the tracks, or there is suddenly rising water. There's so many things which can go wrong in the world, and it's part of that big challenge of being in the actual uncontrolled physical world of the city, and not in a warehouse or on a test track. And it's tough, and there's no one answer to it.
Out of curiosity, when a person is trapped in a Zoox vehicle for whatever reason, say the Zoox vehicle also ends up on the tracks of a train somewhere, can the person get out? Like, is there an emergency mechanism where you can open the door and leave the vehicle?
I'm reluctant to make a definitive statement on this one. My own experience of driving in Waymo is that there is a physical button.
Uh-huh.
That you can push, and that will get you out the vehicle. I'm actually not clear about the Zoox support for this.
And I think especially the incidents where there's harm to people that can happen, they are typically very, very high profile. I believe that Cruise had an accident in the past that actually led them to pause operations. From your perspective, how do these accidents affect the industry as a whole and companies in particular?
Media and the public are very, very sensitive to these accidents, a collision, a injury, and in the worst case, a fatality happens. There's a large amount of attention that it gets, and it can really be problematic for an autonomous vehicle company to. It's a challenge that they have to handle it in the right way. They have to be transparent. They have to disclose the full context of what has happened in the incident. There have certainly been a number of these that Zoox has been involved in. Every time I've heard about them, I've been impressed at how they did achieve that transparency. They were very clear about the context of what happened, which is very important. But yeah, it can because there is just so much attention to the technology. It can be an accident which is really bad involving a human. It can also be something simpler, but also traumatic, like a dog was rolled over, or in a recent case in San Francisco, a cat was killed. And because it's an autonomous vehicle, if a human driver had run over a cat, there might have been outrage. but because it's an autonomous vehicle, this makes the national press. And it will be in the New York Times, and there will be there's a company that people can protest against, and so the magnitude of the incident is amplified vastly, and that's something which the relationship with the public that Alphabet or Zoox does, Waymo or Zoox does, is hugely important because it's so easy for the incidents like this to really become a huge problem.
Well, let's perhaps zoom out a little bit further. We talked a lot about challenges and obstacles and what companies are doing to overcome them. And well, we said that different companies, they are making very different strategic choices. Why do you think this is, and what do these choices tell you about how they are thinking about, the wider industry landscape and the self-driving vehicle business as a whole?
I think there are choices being made about the kinds of hardware which a company is willing to invest in, and that often has to do with where the company, what the company's context is. So you could understand why a company like Tesla is making decisions which are very different, because it's a car manufacturer already, very different from a company like Waymo. The level of vertical integration, if you will, is part of the economic decision which is being made. The partners which are being chosen, Waymo is collaborating with a Chinese company called 𝐊𝐶𝐶 in its next generation of autonomous vehicle. So that the software and the hardware are being done by different companies, and they're breaking down the problem into smaller spaces. And then it's because it's a complete industry. There are companies that are just tackling like parts of it and have decided we just look at this one aspect. We will make these excellent like autonomous truck units and just do that. And so how the braking or the sensors and so on are done, this is something which we specify in terms of its APIs, but we don't attempt to tackle.
And if you step back and look at the industry as a whole, like based on what you have seen, how would you characterize where the self-driving industry is right now? Like, are we still early? Are we in the middle? Or are we possibly even further along than many of us think?
I think that we, no one could say that we are early. The vast number of predictions were that we would already have like widespread self-driving ability by now. So it's been a path which has been characterized by delay and by overconfidence or over optimism. So that's an aspect, but I would also I personally clearly believe or deeply believe that we have also reached a point in which the technology has been proven. And in the last couple of years, as more and more services are on the streets and are successful, despite all of the setbacks, despite all of the companies that have not made it. And there have been many, the tracking space, 𝐾𝐤𝐬𝐷, and others in the autonomous vehicle space, Apple, passenger cars, Apple and Cruise, and again many others. They've all stopped their operations, but we have successful fleet services which are transporting thousands of passengers on a daily basis. So we've reached a point in which it's been proven, in my opinion, and there's no going back.
Beyond this proof point, I mean, coming from the various obstacles that that were already overcome, what else needs to happen before self-driving vehicles become truly mainstream and say, I can go out to my car dealer tomorrow in Germany and buy a self-driving car?
That's not the goal of a company like Zoox, but definitely the goal of other companies. One important aspect of this is the ability to drive the car wherever you want to drive it. The way that current services are operating is that they are geofenced and spend considerable time and effort on mapping out and planning the area of service for you to be able to go to a car dealership and say, I want an autonomous vehicle and I want to drive it out. I want it to drive itself out of this car dealership and I want to drive it back to my home, which is in a different part of the city. Maybe the expectation there is that the vehicle can drive everywhere, and that's something we are some distance off. That's certainly something which a company like Tesla is tackling head on.
And maybe let's briefly just touch on two possible use cases that I think could be very interesting for people that still want to own their own car. And perhaps you could comment on them just based on the visibility that you currently have. And one use case is, say, people want to go to work and come back from work on a daily basis. And they get in their car, they drive this way back and forth 100 times on an entire year, and the car just observes and learns and learns and learns. And then in year 2, it actually knows the way very good and then can drive the work route itself. And the second use case that I have in mind is if you want to go longer distance somewhere, say from Munich to Berlin or from New York to Washington, that you as a human, you still drive onto the highway, which I think is, in terms of complexity, more difficult to navigate through city traffic and just make your way onto the highway. But then, which is the bulk of the journey anyway, let the self-driving car do the highway portion of this itinerary. How do you think about these two use cases?
I think having the car doing its regular commute is something where we're not too far off of that. The problem, I mean, knowing the route and being able to handle the route is an aspect of that, and obviously this would hugely free up so much of our time if we could not have to spend that commute time focusing on the road, but could use it for work or for family or for other things that would be fabulous. There is definitely the aspect of being able to do this anywhere, but this is definitely feasible. And then for your second scenario of long distance travel, I think that there's like so much advantage for having coordinated systems on the freeway. If you think about smart meters or smart speed limits, for example, where you could imagine freeway systems where the cars are getting speed restrictions dynamically and know that there is a problem up ahead and are slowing down, but also where just the capacity of the freeway increases because the autonomy works between the vehicles as well. And so you could imagine just being able to kind of coordinate the sequence of vehicles amongst each other so that they can make use of the freeway space both more effectively but also more safely with less lane changes and etc. I think there's tremendous potential there, and again would just free up the time that people would otherwise be spending on focusing on stressful driving.
Well, I believe we touched on many aspects which are highly relevant in this domain of self-driving vehicles. What didn't we talk about yet that you think is relevant for our audience members?
Let's see. we could talk about how safety is measured. I think that's really important, and how vehicles are, or how autonomous systems are expected to meet certain minimum criteria before they are released. That would be one thing that I would call out.
Yeah, I mean,
another would be human perception of autonomy.
let us maybe dive deeper into the safety aspect, and we did talk about this at least in some regard. To what you mentioned, how's safety being measured?
So typically, you would have a set of core North Star metrics that the autonomous vehicles would be expected to meet before driving on public roads. And as a simple example, you could have something like a number of kilometers driven before there is a collision, which is the fault of the autonomous vehicle. So this could be a metric, and defining that metric, and then measuring it, and making sure that the new version that you are wanting to release can actually meet those target levels for your release is part of the system. And then the question is like, well, how do we actually measure these collisions? Obviously, we don't want to have them, and that's where your simulation system would come in. And so your log replay and your ability to variance of some of the training drives, where you make things different and see how the vehicle responds, and you are then able to measure exactly what that North Star metric is, like what is the predicted number of kilometers that given this model we would drive before there was a collision that we caused, before there was an injury that was our fault. That becomes something that you can measure, and then being able to meet that is your gateway for, or one of your many gateways for getting a safe system out. And of course, you would be measuring it on the fleet as well, but you don't want to measure your fatalities on a live fleet, as that's not your data signal.
Do you actually think it's possible that maybe by 2030 or 2035 or any time frame, that companies like Zoox and others who are operating shared services in urban environments will be able to operate without any accidents?
I don't know about any accidents, but definitely like a much lower accident rate than we currently have, and that's already true. The statistics that we already have, the data which we already have, and all of the target benchmarks that companies like Zoox have, they have to be better than humans, and they are substantially better than humans already. Being entirely accident free is really hard. Just like being absolutely outage free, you can have your 3 nines, your 4 nines, your 5 nines, but having no outages whatsoever is almost impossible. Having no accidents whatsoever in a world which has so much strangeness in it and so much unknowns, I'm not sure that that's ever achievable. But being able to, like, having a vastly better safety record than a human driver is definitely there. And if I remember correctly, the Waymo data says something like 83% fewer accidents than a human driver.
And let's actually assume it's 2035 and self-driving cars are everywhere. They are relatively safe, a lot safer than they are today. How do you think transportation looks like? How will transportation in cities in our daily life look like in 10 years down the road?
Yeah, it would be good to think of there being less private car ownership. That's definitely a goal, or an underlying assumption on some of the models. you could see something akin to the kind of the very easy ability to grab a city bike and get around on a city bike these days. So there's just ubiquitous autonomous fleets that it's easy to get along further distances as well. And so being able to cheaply reach from one neighboring town to the next via an autonomous vehicle is straightforward. I could also see there being an impact on transit systems. And so that's an interesting topic to think about, like what might happen in this world in 2035 if it becomes easier and easier to get an autonomous vehicle and cheaper. How does that impact our trains, our buses, and these alternatives that we have? And is that going to make the city necessarily a better urban environment if there are just many, many more vehicles, even if they are safe and electric? But it is an aspect of a potential aspect of the autonomous fleets as they get rolled out.
I think it's fair to say that even today there's already and there was a lot of hype around self-driving vehicles. From your perspective, I mean, do you think the hype is justified, or are we just being overly optimistic about technology here?
I think the hype maybe is not justified. Maybe some of the statements which are being made recently about robotaxis in general, you always want to be a little pragmatic about where you're thinking, but I definitely think that the economic potential, as well as the potential to change our mobility, is definitely an aspect that this industry can realize, and so I'm very excited about it.
And I think you're not the only one. In fact, a lot of professionals, they are fascinated by the self-driving vehicle industry as a whole. You, as someone who has worked in this industry, what advice would you give someone who wants to break into the world of self-driving vehicles from a professional perspective?
I would, if you are interested in the technical side, which is the world that I'm coming from, being able to understand better the technology is something which is very accessible today because there's just so much excellent like online material. So just getting a good grip of how they work, using any one of a number of like excellent online sources, and those are increasingly becoming available for people who maybe are not as comfortable with coding as a software engineer would be. So that's definitely something which is available. If you're familiar with many of the data sets are there as well. If you're lucky enough to live in an area which has one of these services in and haven't yet done it, it's just, there's so many of my friends have never done it before, and just like jumping in one of the vehicles to experience what it is can be so inspirational. And the companies are growing, the companies are expanding. There's a lot of like across all roles, and it's not just. We were talking about this a little earlier. It's not just tech that's needed. The fleet management, the operations. There's a growing need for really good professionals in many aspects of the operations and logistics of the charging stations and so on of the fleets. So
There seems to be a common thread between many of the frontier technologies that are currently being developed. A lot of the aspects in the physical world seem to be very high in demand at the moment, be it in, as you explained, self-driving vehicles to, service the cars, be an engineer, maintain them, think about logistics and implement logistical aspects. And then when you think about electricity, the grids are under a constant consumption at the moment. They need to be built. Infrastructure needs to be improved. There is this advice that plumbers and electricians will have the decade of their lives coming up. Would you sign on to that statement?
I don't know if I would sign on to it. I think everything is changing, and things are changing for the electricians and plumbers. The physical, the stuff. So the physical world, which can't easily be automated. Yes, many people are predicting that's a safe haven from all the change that we have around us. I think there's some truth in that for sure.
Well, Will, then let's actually start wrapping up our discussion for today. And we have a closing tradition on this podcast. So I'd like to ask you, is there someone or something that's inspiring you right now? Like, is there a leader, a book, an idea, something else that is expanding your thinking?
It's not particularly autonomous vehicle specific, but someone that I would call out as a really great source and orientation with all the changes that we're seeing around us is Andrew Ng. He was very influential at Google. He's a renowned Stanford researcher. He came in and provided the impetus for what became Google Brain, and is also just a tremendous educator. So I follow his newsletters. He has a newsletter called The Batch, and he talks about all the various aspects, including autonomy, but not limited to it, of AI and how it's changing. He does that in a way which takes a complicated topic and makes it very accessible. I would recommend the newsletter, and he's also just a really good educator, and he has an educational platform called Deep Learning AI, which allows people at various levels of familiarity with the technology to understand it better. And there are some excellent ways to get to be more familiar with some of the technologies that we've been talking about on that platform. He's also, I think, a techno-optimist, and he's talked a lot about how what's happening around us is providing opportunities, and that's true for coders. It's also true for many other people, and so it's easy to be alarmed or anxious about the amount of change that we have at the moment, and so having optimism, which is knowledgeable, is something which I appreciate from him.
Right. And for coders like yourself, you're a software engineer. Do you think the skill will become less relevant in the future?
It's a very interesting question, and I would like to say no. I think it's going to be very relevant, but in a different way. It's definitely being impacted largely through the AI coding tools, but in many, many different ways. And I think it will be very different profession, but a very one which continues to be in demand.
And Will, if listeners remember just one thing from our conversation, one insight, one way of thinking differently, or one action that they should take, what would you want that to be?
I'm going to call out just my own experience and observation in riding in autonomous vehicles, is how quickly it becomes mundane. And we haven't talked about this earlier on in this interview, but by the time you take the second ride in an autonomous vehicle, it already becomes something which is almost commonplace, and you just accept it. And if others have that experience, to think about how that demonstrates the success of the technology, because something which is so complicated and so critical for your personal safety blends into the background and becomes something which you can ignore, for me is worth taking notice of.
Well, William, let's wrap up our conversation for today. Thank you very much for coming on to the show and sharing your insights on autonomous vehicles. Thank you very much.
Much appreciated the opportunity. Thank you so much, Florian.
Before we wrap up, let me highlight what I believe are the key takeaways from this conversation with Will. First, we discussed where self-driving vehicles actually stand right now. And the honest answer from someone inside the industry, from Will, is they work. They are operational. Thousands of passengers are using self-driving vehicles daily in real cities. So the technology isn't theoretical anymore. If you've been waiting for the proof point, we're actually past this. And what this means for businesses or for any industry is that this isn't something distant. It is happening right now in specific cities with real implications. Second, Will and I talked about why different companies are making completely different technical choices. We talked about Tesla versus Waymo, Waymo versus Zoox, and they aren't picking random paths. Rather, they are all making their own very calculated bets based on where they started, what they are optimizing for, and their individual risk tolerance. And understanding those differences matters because it tells you something important. There isn't one clear winner in terms of emerging technology, at least not yet. Multiple technological approaches might actually work. And that creates competition on the one hand side, but also uncertainty in the market. And finally, Will and I touched on something that I think is very practical, and that is job impact. Yes, professional drivers face real disruptions, they face real risks, but we also discussed how companies are simultaneously in need for a different type of worker, more skilled work fleets, including operators, maintenance specialists, data engineers, and logistics coordinators. The market opportunity is also bigger, possibly bigger, than just replacing today's rideshare services, because arguably more and more people would be using self-driving vehicle services. It's building an entire new mobility ecosystem, and that matters if you're thinking about workforce planning or even about investment opportunities. Now, the practical bottom line is self-driving vehicles are real, they are operating today. What is uncertain, however, is which companies will succeed and how quickly this scales. Now, a few final words. If this conversation resonated with you, whether you're fascinated by how self-driving technology actually works, whether you're curious about where the industry stands right now, or whether you're simply interested in the business challenges beneath major technologies, please subscribe, like, and share. You can also find links to everything we discussed today on our website, businessunbound.co. There, you'll also find ways to connect with Will directly if you'd like to explore the self-driving space further. And while you're visiting our website, please subscribe to our newsletter. You will be the first to know when new episodes drop, giving you early access to conversations with forward-thinking leaders who are building tomorrow's business world. Now, thanks for listening. This was Business Unbound for today, and until next time.